Hello, Algebra 1. Today we are starting our new unit, and this unit is going to be all about solving quadratics in lots of different ways. The first method we are going to learn about is solving by square roots, which we will begin tomorrow. But first we have to talk about how to simplify square roots, and we're going to do that using both factor trees and perfect squares. So knowing your perfect squares is very important in order to simplify square roots quickly and efficiently. And these are the first 12 perfect squares that we want to go ahead and evaluate. So these are ones that you should have committed to memory. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And finally, square root of 144 is 12. So recognizing those numbers would be really helpful in order to simplify square roots quickly and efficiently. All right, so let's practice those. Remember, perfect squares lose their radical once you evaluate. So what makes them perfect is that they no longer need the square root on top. So let's see if we can figure out the following problems. The square root of 9 is 3, and that's because 9 is just 3 times 3. So 3, and then we're just going to multiply by 2/3. 2 times 3 is 6, divide by 3 is 2. All right, square root of 100 is 10, and that's because 10 times 10 is 100. 10 over 5 is just 2. Square root of 16, this is 4 times 4, so square root of 16 is just 4. Square root of 4 is 2 times 2, so this is just 2. And 4 times 2 is 8. All right, you could also go ahead and multiply these first. 16 times 4 is 64, and then square root of 64 is 8 times 8, and so that is just 8 as well. All right, so having perfect squares is easy, but realistically, most radicals do not have perfect squares. So we're going to use a factor tree to help us simplify a radical to give what's called an exact answer. An exact answer means there are no decimals. Okay, so we're not rounding at all. This is kind of like math fracking a radical, okay, which your calculator doesn't do, so we're going to show you how to do that. The first thing you're going to do is you're going to break 12 down using any numbers that you know that multiply to 12. It is helpful to use perfect squares, but you do not have to. So for example, I know that 4 times 3 is 12. The reason using perfect squares is helpful is because you know you have an automatic pair there. However, if you decide to use two different numbers like 6 times 2, you can still break 6 down to 3 and 2. And what you're going to notice is in both cases, you have a 3 and you have 2 2s. Okay, so you're breaking down to the same prime numbers. So we stop once we get to all prime numbers. And prime numbers are numbers that cannot divide by anything else other than 1. Now, all of your teachers are going to show this slightly differently, but the main idea is that you are looking for a pair of numbers, and your pair comes out, whereas your radical, or your leftover number stays underneath your radical. So here's what I do. Whenever I see a pair, I circle one and I cross out the other. Okay, and whenever I see a number that doesn't have a pair, like the 3, I underline it. Anything that's underlined is going to go under the root. Anything that's circled, which is our pair, comes out. And our answer for this is 2 root 3. Okay, so that's how we would actually say it, 2 root 3. All right, so let's try another one. Again, it doesn't matter which numbers you use as long as they actually multiply to the number under the root. But if you use perfect squares, it does speed up the process. Okay. All right, so we're going to start with 48. 48 I know is 8 times 6. 8 is 4 times 2. 4 is 2 times 2. 6 is 3 times 2. So I'm going to look at all of my primes here. Primes are at the very end of your tree. I have a pair of 2s, so I'm going to circle cross out. I have another pair of 2s, circle cross out. Again, notice they're not right next to each other, but that's okay. 3 does not have a pair, 3 gets underlined. Anything that's underlined goes under the root. Anything that is circled, both of those are going to come outside the root and multiply together. So our final answer is going to be 4 root 3. Now, if you noticed that 48 is 16 times 3, and 16 is a perfect square, what's nice is that 16 breaks down to just 4 and 4. Now, technically those 4s continue to break down to 2s, but since you already have a pair right now, you can circle cross out, underline your 3, and if you notice, that goes straight to that 4 root 3. So using your perfect squares doesn't change your answer, it just makes it a little faster to get there. Okay. All right, let's go ahead and try square root of 72. So I know that some numbers that multiply to 72 are 36 and 2, and 36 is a perfect square, but I think most people will probably go to 9 times 8 first, so I'm going to use that. Okay, 3 times 3, 4 times 2, 2 times 2. So I'm looking at my primes. 4 is not one of them, it broke down, so it's just the 2s and the 3s. And now I'm looking for pairs. I have a pair of 3s, circle cross out. I have a pair of 2s, circle cross out. I'm going to underline this leftover 2. Okay, underlines go under the root, circles come outside, and we're going to multiply those together. And 6 root 2 is our answer. All right, let's try 20. 20, I know 4 times 5 is 20, but you could also use 10 times 2. 4 breaks down to 2 times 2. Okay, so my primes are 2s and 5s. I have a pair of 2s, circle cross out. 5 doesn't have anybody. Again, underlines go under the root. Circles go outside. Now, if you're not sure what numbers multiply to something, so like 125, this is a little bigger. What you can go ahead and do is just start with 125, type it into your calculator, and start dividing by numbers. Don't just pick any random numbers and start like multiplying and seeing if you get 125. You're going to be multiplying forever. You're looking for a 125, start dividing by numbers until you find something that works. So 5 times 25 is 125. And now 25 breaks down to 5 times 5. So this is just 3 5s. Okay, that still means there is one pair, circle cross out, there is one that's left over. Circles come out, underlines go in. 5 root 5. Now, number 5, we have to be careful. There's a negative underneath the square root. This is not possible because there aren't any two numbers that are the same that multiply to a negative. Okay. Whenever you have two numbers of the same sign, they always multiply to a positive. So this is not possible, and we say this is undefined. Okay, anytime you have a negative underneath the root there, we call that undefined. Now here, a negative outside the root, that's okay. That's just kind of like a -1 that's hanging out there, and it'll multiply by anything that comes out of the root, like our 2 up here. All right, 24, I know is 6 times 4. Keep breaking these down until you're to your primes, which are these guys. I have a pair of 2s, circle cross out. This time 2 and 3, neither has a buddy. So underlines go under the root, those are going to multiply together. Your circle comes out, and then don't forget you have that negative out front as well. So this is -2 root 6. All right, so let's just practice a little more. We're going to simplify when we have a number in front of our radical. Remember, numbers outside the radical do not multiply to numbers inside the radical. So you can use factor trees or perfect squares. It is up to you. We'll be doing more with radicals in the future. This is kind of an introduction to that. All right, so your number in the root, that's what we're going to break down. I'm going to do 4 times 11. 11 is bigger, but it's prime. Okay, in fact, let's list our prime numbers up here. We've got 2, 3, 5, 7, not 9, 11, 13, and so on and so forth, but I think these are probably the most common ones that you'll see. So when you hit one of these numbers, you know that you're done, okay? You can't break it down any further. All right, again, you are looking for your pair. I have a pair of 2s, and 11 does not have a pair. Underlines go under the root, circles go out front, and actually you have this -2 as well, so it's going to come on down as well, and it is only multiplying to the 2. So this is a negative 4 root 11. All right, let's try a few more. 20, break it down. You have 5s and 2s. Pair of 2s, circle cross out. 5 doesn't have a pair. Let's put it under the root. The 2 is going to come out. But wait, you're not done. You had a 6 out there as well. So that's multiplying to your 2. 12 root 5. 60. I'm going to do 6 and 10. Make sure you break everything down until you hit those prime numbers. Okay, so we're looking at these 4 numbers. We have a pair of 2s, circle cross out. That means the 2 is coming out along with that 1/2. 3 and 5, those are underlined, so they're both going to go under the root. And then we simplify. 1/2 times 2 is 1. 3 times 5 is 15. All right, last 3 here. 90 is 9 times 10. Make sure you keep breaking 9 down. Keep breaking 10 down. These are my primes. I have a pair of 3s, circle cross out. 5 and 2 do not have pairs. Underlines go under the root. Circles come out front, along with this negative 2/3 here. And then we'll simplify. Negative 2/3 times 3 is negative 2. 5 times 2 is 10. So negative 2 root 10 is your answer. All right, now be careful with number 5, because if you know your perfect squares, you should recognize that 36 is one of them. So we do not need to do a tree for square root of 36. Square root of 36 is just 6. That's it. It doesn't have a root over it. It is a perfect square, which means my 6 comes down, my negative 3 is out front. This multiplies to negative 18. Okay, again, perfect squares lose their root. And finally, number 6, don't just jump to do your factor tree because we have a negative underneath this root. That means automatically this is again called undefined. All right, so that's your introduction to factor trees. We'll be working more with these over the next several days. Have a great day. Bye.